All right, welcome out to my presentation. This is a training on Wireshark. It's geared towards beginners, so if you don't have any experience with Wireshark, that's perfect. If you have a little bit of experience with Wireshark, that's probably okay too. If you've been using Wireshark for years, you may pick up one or two tricks, but this training is probably not for you if that's the case. So I just want you to be aware of that right from the beginning. A couple things about me. One, I don't like to stand behind the podium, so I'll be moving around a lot. I've been to SAINTCON for 7 years in a row now. I started coming in 2014, and 2014 I just came, tried it out a little. 2015 I volunteered as a security person, and then 2016 I started doing presentations, and I've been doing that ever since. I love SAINTCON. How many of you, is this your first time here at SAINTCON? Sweet. Okay, so it's awesome. I learn a ton, make great friends, build network connections. It's really one of the best conferences that I go to. In fact, I would say it is the best conference that I go to. My wife always complains that when I go to SAINTCON, I'm not working, I'm just having fun. Right? You get to go party for a week. And that's really what it feels like. Right? It is work, it's learning and opportunities to grow and develop, but it's also a ton of fun. Okay, so in my day job, I teach at Weber State University. I'm a faculty in computer science and, the School of Computing there. I've been there about as long as I've been coming to SAINTCON. That was how I got introduced to SAINTCON, was through my work there. They used to host the conference up at Weber State. So I've been doing that. I occasionally teach an entire class on Wireshark up at Weber State University. So this is a very condensed version, right? Usually when I cover these kind of topics, I get to spend 15 weeks talking about Wireshark, and we get to go into tons of detail. Instead, you get the highlights and the condensed version in 2 hours. And hopefully it's enough to get you started and figuring out how to use it, and to then go on from there to learn more about all the great things you can do with it. I should have had this slide up the whole time I was talking. I kind of forgot that that's what I was going to do. If you haven't already, download Wireshark. You don't need the absolute latest version, but if you're downloading it, you might as well download the latest version. But any recent version will work. It hasn't changed too significantly in terms of the interface or anything, or any of the features that we'll be using in this talk. So you'll be fine if you have a recent-ish copy. You'll be fine there. And then in this training, it's very hands-on. I'll be up here on the stage sometimes, but lots of times I'll be down there walking around, helping through the different capture files that we're working on. So we are not doing any live captures. Instead, I have already captured some traffic and made those available at the second URL here on the sides. That's the short URL one. That's just a link to a Google Drive folder that has 2 files in it. It has the capture files in a zip file, and it has this presentation so that you can follow along and come back to it and move through it as needed. Okay? So a few things about this presentation and what we'll cover and that kind of stuff. First off, I start with the disclaimer of you should know the law and you should know company policy or your organization's policy in terms of capturing traffic. There can be and often is sensitive information on our networks, and Wireshark is a tool that lets you see anything that's on your network. And so there are laws and company policy that sort of govern the use of monitoring your network traffic. And so that's not one of the things that I cover in this presentation is when you're okay to capture traffic and when you're not, and if you're right, if you have the right permissions and stuff. I leave that up to you to work out with those who are in control of the networks that you're capturing on. And so with that, that's another reason we don't do any live captures here. That way, we don't have to worry about it. Right? I've already captured the traffic we need to work with. So we won't be doing actual live captures. We will talk about how to capture and where to capture the traffic. So those will be some skills that we do cover. In terms of other skills needed, there's the obvious skills that come with network security, and in terms of like curiosity, an analytical mind, right, those kind of things. Again, those are not what we're going to be covering here, but are critical to success in understanding what's happening on your network. We're focusing on the technical details of how to use Wireshark. We also will briefly talk about some of the network protocols, but to be really good at using Wireshark, you have to understand what it is you're looking at. You have to understand how the devices are communicating. And Wireshark will help you do that, but it's also helpful if you already have an understanding of the protocols you're looking at. Right? So you understand the basics of how the HTTP protocol works or how the ARP protocol works. Right? And so, again, in this 2-hour training, we don't have time to cover all the protocols in detail. We'll do a high-level introduction to a few of them to kind of give you a taste of the types of things that you can be doing on your networks and with Wireshark. So let's start just with a basic tour. I try and make the presentation accessible to a large variety of individuals with different skill sets. Right? So some of you are like, okay, yeah, I've seen Wireshark before, I don't need a tour, and that's okay. We won't spend too long on our tour of Wireshark. But I do just want to go over some of the key elements of the interface, and then we'll get into more of the details of using that. Just let me pause for a second. Are most of you able to have the capture files downloaded and Wireshark downloaded at this point so that we're able to kind of follow along and work through this together? And do we need a couple more minutes to download things? Okay, so it sounds like we're good. This is going to be slightly problematic in terms of when I'm presenting and not presenting what's showing on my screen. I think we can make it work. That's really small on my presenter monitor. Is it small on the thing there? Yeah, and there's lots of seats up front here too, so let me try. I can change like some of the settings that will make a few of the things larger, but I think if I switch my presenter mode, that might help as well. Okay, see if that improved our resolution over there. There, that's better, right? Okay. So, quick tour of Wireshark. Like most programs, we've got our menu options here. One of the best things you can do in terms of learning Wireshark is just explore those. I talked about curiosity being an important mindset and skill to have. And that's one of the best ways you're going to learn is just try things out and see, well, what happens when I look at these different statistics? Can I start to learn things about those? And we'll explore some of those in a few more details here in a minute. I'm going to open up a capture file here. So I'm going to start with the baseline PCAP file. that should be in your set of downloads, and that way we can just have a common file to work through for a second. We have three main areas here in Wireshark. The first area is our packet list, and so it's showing a list, you can see numbers 1, 2, 3, 4, 5, of all the packets that were captured in this Wireshark capture, and a few of the details, right? A timestamp, where it came from, where it was going in terms of IP address, some basic information about that packet. This is customizable. We'll get into that. The second thing you're seeing here is your packet details. And so as I change which packet I have selected, right now packet number 1 selected, it's showing me then all of the details of that packet. And it breaks it down by the different layers in the packet. And so we can start with our application layer, say, okay, this is a DNS packet, here's the details of that DNS packet. And you can see all of the information that was being sent as part of that DNS query in this case. And then you can go to the next level in your protocol hierarchy and say, well, it was sent using UDP protocol, and here's the details, right? It was this port, this length, etc. And that was wrapped in an IP packet, right? And you can see the IP address and all that. So all your details of this individual packet show up in your detail list. As you change to, so I'm going to jump down here to like packet number 5, right? Your detail list changes, because now you're looking at the details for that particular packet, okay? And then finally, the last section is the packet bytes. And so ultimately, right, the packet just corresponds to a set of bytes that were sent across your network. And so here are those bytes in hexadecimal format and then as ASCII characters. And so as you are working in your detail list and you click on a given segment, it highlights the bytes that correspond to that segment. So again, I like to think of it as sort of drilling down. You start with the packet, then you get the details on the packet, and then you get the details on the individual bytes of that packet. Okay? You can move around those windows. You saw me dragging them up and down. You can choose other layouts, put one of them on the side, on the right, or the left, or whatever. I typically will use this 3-line layout when I'm working with it, and unless I need to see the bytes, I usually will shrink that one way down, because I most of the time don't care about what the actual bytes are. I just care about these packet details, and so I like to keep most of my window able to see those 2 items. Okay, so we talked about the menus. We skipped the filter bar because I'm going to cover it in more detail, and we skipped the status bar. Let me just quick. The last thing here down at the bottom is our status bar. It has some details on your packets, like how many packets are in the capture file, how many of those are being displayed, what profile you're currently using, and again, we'll get into changing some of those options here in just a second. Okay, any questions about the general interface of Wireshark? Hopefully we didn't spend too much time on that and lose anybody here. It looks like you're at least still sitting and not sleeping, so that's good. The next thing we need to talk about is where to get these packets from. Okay, we're not going to do the actual live capture, but I do want you to have the ability to go home and create your own packet captures and get some interesting data with that. And so let's talk about that for just a second here. If I've got a sample network, this could be a home network, it could be an enterprise network, whatever. My images here, N5, N7, those are basic switches. N3, N6, N4, those might be more like routers. Right? N6 being a wireless device, so that then we have our wireless network, we have our wired network, we have the ability, those are connected together so that they can talk to one another, and ultimately, this N4 might then be connected up to the internet, right, for general connectivity. So if this is my network setup and I want to capture traffic on this, where should I go about doing that? Okay, so I heard someone over here speak up. N3 if you can. Okay, why N3? Yeah, N3 is sort of this central point where you're going to get traffic from N10 to N8 has to flow through N3. Right? Traffic from N2 up to N8 has to flow through N3. So in terms of capturing the most traffic on your network, that's probably going to be the ideal point to capture. Now what about if I'm working, trying to find a specific problem? I've got my desktop computer, let's call that one N10, and I've got my laptop, and we'll call that one N12. And I'm trying to share my files between them or whatever, and it's not working, and I want to see what's happening on the network, try and see if there's something there of why it's not working. In that case, will N3 be a suitable place to capture traffic? No, right? Because most of the time our switch isn't going to bother sending it to N3. It's just going to go straight from N10 through our switch into N12. And so if we're capturing on N3, we probably aren't going to see that traffic. And that's the main point I want to make here, is that there's no right place to capture traffic. The right place is wherever the traffic's flowing that you want to see. Okay? There are things you can do depending on what kind of devices you have here that will let you capture traffic either better or worse. And so if your switch has the ability to do what's called port mirroring, and you can say, hey, I don't want to just capture traffic on N10, I want to capture all the traffic from this switch, mirror all the traffic that you see, right, and send it to this one port, and then we'll capture out on that port. And so if you have a switch or router with that capability, you can enable that and capture the traffic. If you don't, well, then you've got to get creative and come up with other techniques and solutions. Sometimes you just care about getting on a specific line, and so you can get a tap, right? A network tap that just, you basically insert a connection right here. Say, okay, whoops. I'm just going to plug my wire coming into this tap and then out to this tap and just insert my device right there so that I can then capture that traffic. Okay? I forgot to bring it. It's in my hotel room. I have a little example of a network tap, just a little square box with 4 connections that lets you capture completely silently because it isolates the network. And so what comes in is completely separate from what's going out, and you can monitor both directions of that traffic without your device interfering on the network. And that's something to consider as well. Depending on what you're doing with the capturing the traffic, Wireshark can generate additional traffic on your network. So that's something to be aware of. If you're capturing traffic and you want to be silent, you don't want to tip off an intruder that you're monitoring what's going on, you'll want to take precautions with that and say, okay, yeah, let me get one of these tap devices so that it completely isolates my Wireshark and prevents it from sending out any traffic on the network. There's configurations in Wireshark itself that you can do to minimize what information it sends out on your network when you're capturing. But again, in terms of extra layers of security is how I like to think of things. Okay, let's go back because I wanted to talk about our wireless network as well. Troy was just in here talking about how things have changed in computer security. That's certainly true with our wireless networks. When I got into this, and was doing my first captures, almost every wireless network was open. It was very rare to have a wireless network that used any type of encryption, and that you had to put your password in, or you had to have the certificate or anything. Right? Those were uncommon. And so capturing traffic in those days was really awesome, right? Because you could see in a wireless device where you're capturing traffic is anything that can see those wireless waves, right, could read that traffic. And so I remember when I first learned about that, I was like, whoa, mind-blowing. So I went home to my parents and pulled it up and was like, hey, Dad, go visit that website or whatever. And I captured it, and then I showed it. I was like, look, here's what you just did. And I saw it all. It's like, whoa, right? Mind blown. I went to, now I'm not sure, is it Dark Matter that does the Wi-Fi cactus? Did anyone else go to that talk? Right, so I went to that one, and he's doing capturing wireless traffic. And it turns out, even though most of our networks now are encrypted and you have to have a key and stuff, if you have that key, it's still able to capture that traffic and decrypt it. So there are options here when you're capturing wireless traffic. It's a little harder to do than it used to be if you want to get that wireless traffic from a wireless card, but you can do it. Any questions about where to capture or how to capture? We didn't go too much into the hows in terms of what it looks like on Wireshark. So this little blue fin, if you've already loaded a capture file, is what, I didn't want to actually start. That's good because I didn't have one. Here we go. When you're in this interface here, you can choose which which network device you want to capture traffic on. And I'm not, plugged into my local connection, and so there's no traffic there, whereas my Wi-Fi traffic, you can see on this line, it's getting traffic. So if I wanted to start capturing traffic live, that's how I would go about doing it. So that's a great question. For those that couldn't hear, he said on Linux you can do TCP dump to capture the traffic, which is super helpful. You can then, you can use what TCP dump captures to then feed into Wireshark. And then he asked about tools on Windows to do the same thing. I typically, when I'm capturing from a Windows device, will just use Wireshark to do the actual capture. I believe there are tools. One tool that's related to Wireshark is the T-Shark, which is basically a command line interface version of Wireshark that you can do if you're wanting to capture from the command line like you can do with TCP dump. Great question. Other questions about where or how to capture? That still has been my experience. So again, to repeat the question, he's saying, wireless NICs or wireless network interface cards. In the past, it's been difficult to get them into monitor mode, to get them to be able to actually monitor all the traffic. And he's asking if that's still the case. In terms of if you just go out and buy a random wireless card or a random laptop and use its wireless card, yeah, it's pretty hit and miss still if you're able to do a good capture with that. But there are specific radios and drivers now that if you know that's what you want to do, you go out and get those ones. And in that case, talk to like Dark Matter with the Wi-Fi cactus, because he can, tell you all about his experience with capturing the wireless traffic. But yeah, for me, it's still been hit and miss on how well a random wireless NIC will be able to capture your traffic. Other questions? All right. So, where did we leave off? Having a baseline. All right. When I teach this class at the university, as part of the class, I have the students do a project, and they can choose whatever project they want. They pick something they're interested in, but it has to involve capturing traffic and using Wireshark. And lots of times they'll say, oh, I'm going to do a capture on my own home network, or I want to see what happens when I'm streaming Twitch, or I want to see what happens when I'm playing this video game, or whatever. Right? And they'll do something like that. And probably like 99% of the time when they do that, they come back and they're like, whoa, I never knew what all this other stuff was on my network. Like, I tried to just look at what happened when I played this game, but there was 100 other things going on my network, and I had a hard time, finding the traffic that was my game. And I got sidetracked because I saw this thing and I thought maybe I was being attacked, right? I saw this traffic and I didn't know what it was. Or I saw this IP address that was on my home network and I didn't know what it was. And so when you start doing a network capture, one of the keys is to have a baseline, to know what your traffic looks like in a normal circumstance, so that you can then find those anomalies and you can find the things that are different, or you install a new service and you can see how it changes your network traffic. And so that's what we're going to work through here for just a minute, is talking about baselining our network and figuring out what normal looks like. So there's lots of different things you can do there in terms of baselining your network. You can look at what protocols are being used in your captures. You can look at how much traffic's flowing, in a given time period. You can look at what the hosts are, which IP addresses are active on your network. And all of that's going to vary for each network and over time, right, as different things change. So having a baseline of what wireless traffic looks like when you're here at SAINTCON is going to be different than what it might look like on your home network or what it might look like on your work network. Right? Every network has a different kind of profile of what's normal for that network. And so we want to know what's normal for our own network, whichever one we're monitoring or trying to look for details on. So I have 4 different capture files in the download that I want you to play around with a little bit, and I'll give you a couple things that you can look at specifically and just see how these capture files are different or similar. So the 4 capture files, the baseline one that we've pulled up, the MAC off flood, the NAT back, and the NAT front. Okay? And so let me walk through a couple things on the baseline, and then you guys can walk through some of those same things with the other capture files, and then we'll talk about it. Okay, so pull open my baseline file again here. And I'm going to start in my statistics and my capture file properties. So this one's going to give me some overall statistics about the entire capture file itself. Most of them I don't care about, in terms of the file itself, so I generally skip over those. The time when the capture occurred, that can be useful depending on what you're trying to do. So you can see, this one was captured 4 or 5 years ago in between these time periods. You can see sometimes information about what device it was captured from, depending on what was available in the capture file itself. But what we care about here for baselining is these statistics down here at the bottom. So we can see how many packets we captured, we can see over what time span, and what that breaks down into in terms of packets per second. So that's our PPS here, is how many packets per second. And then the size of those packets on average, total number of bytes, and then average bytes per second and average bits per second. And so that, at a very high level, is going to give you some statistics on your network of how much traffic was flowing during that capture. Also in our statistics menu, we can look at our protocol hierarchy. And this is going to give us a different way of breaking down the traffic This breaks it down by what protocol was used as a percentage of the total traffic captured. And so all of them were using frames and Ethernet. Right? So 100% of the packets we captured were captured that way, which makes sense since we were capturing on a Ethernet device. Right? Some of the traffic was using IPv6, but not even high enough to register as a percentage of our packets. Right? It was just 2 packets that showed up like that. Most of them were using IPv4. Of those, right, so this is like drilling down. And so of the ones using IPv4, then 4% of them were using UDP, 95% of them were using TCP. And so it breaks it down, and then further, which applications were being used, and that can give you a guide, an insight into your network of, okay, how much traffic am I seeing that's HTTP traffic? How much of it is FTP traffic? And start to get a feel for that. The other one that we'll look at right now is this endpoints. And so the endpoints has tabs at the top that, again, correspond to our different protocols. And so it depends on what level we're talking about in terms of our network hierarchy for looking at endpoints. So we can look at endpoints at our lowest level, right, closest to our actual physical network, and look at the MAC addresses that were observed in this communication. We can move closer to the application at our network layer and look at what IP addresses were observed in this communication. And not only which IP addresses or which MAC addresses, but also some statistics about them. How many packets? How many bytes? How many of those were being transferred? How many of them were being received? Okay, and we can do that for each of our levels through up to the transport layer. So then we can look at TCP and UDP. That'll include both IP address and port number and break it down that way. Okay, so let's start with that. I've kind of walked you through looking at statistics for our baseline file. What I want you to do is now pull open those other 3 files, the MACOFF file, the Nmap, not Nmap, the NAT back and NAT front, and just do a little comparison. How do those compare to our baseline? What do they look like? How are they similar? How are they different? And we'll take maybe 5 minutes or so to work through those, and I'll walk around if you have questions about the statistics and stuff, and then we'll come back up and talk about it up front, okay? Okay, if you need the link to download the files, it's up here while we're walking around. Okay, so here we go. What did you guys find as you were looking at that? What were some of the similarities in these capture files, and what were some of the differences? Yeah. The flood one? Okay, yeah, so you're in the, no, let's pull it up and flood, no, it should have been in my recent list. So you're talking about here in the file statistics, right? Let it finish loading so it can tell us about it. There we go. So hardware is unknown, as was the other one. I get OS and applications still being detected. Is that what you're seeing, or are you seeing something different? Yeah, so this one, you're talking about the Mac-off flood, right? And the endpoints. Yeah, right? Look at those IP addresses in terms of, and how they compare to what we were seeing before. Okay, good. Other things you guys notice as you go through these files? Okay, great. Yeah, so you're talking about, how fast it is. So let's look at that when we check out these capture file packets. So this one's doing an average of 1,245 packets per second. And whereas the baseline was, what, 50 or something like that? Yeah. Okay. Good observation. Other things you guys noticed? Okay, so nat back. And seeing lots of SSH traffic, right? That's what you're talking about? Good, so yeah, seeing more of a particular kind of traffic in this capture file. And for those, right, so we can sort of follow along. One way that we could see that is in our protocol hierarchy. And we can see, oh yeah, 11% of this traffic is SSH traffic. Yeah, let's do that. That's a great question. Let's dig into that question a little bit. Okay, so we've pulled up this file, we've pulled up our protocol hierarchy, and we're looking at it, and we're saying, wait a minute, this doesn't look normal. This is different than our baseline. What's going on here? And so the observation he made was there's a couple packets that have an application layer protocol and even a TCP, well, a UDP, right, transport layer protocol, but only 2 of them. Right? Out of the 76,000 packets we captured, only 2 of them have any recognizable transport layer protocol or higher. And so one of the questions we might ask is that just because it's not detecting what the transport layer is? Well, let's take a look at our packet details and see. So as I select in my packet list, and I'll just start with the very first one, what we actually see is when we go into packet details is the same thing, is it's only breaking it down into those first 2 layers, or our Ethernet layer and our IPv4 layer, and there's nothing below that. When we look at the bytes that show up with that, there are bytes beyond the IPv4 protocol. There's these additional, what is that? That's like 10 or 12 bytes, it looks like, of data that isn't being classified as anything. So, yeah, it's close to what you were saying. Like there is something there after our network layer, but it isn't a typical UDP packet or a typical TCP packet or anything else that Wireshark knows how to recognize. And Wireshark knows how to recognize a lot of protocols. As a side note here, if we go into preferences and click on the protocols, we can see all of the different protocols that Wireshark knows how to recognize. And it's none of those. Okay, so that was a good observation. Other things on these files? Let's continue on here. Is it okay if I don't go back into presenter mode? You can see the slides okay like this? Switching back and forth is a pain. Okay, so we've done a little bit of baselining. We've seen how some of the packet captures are similar, how some of them are quite different. Let's talk a little bit more about how to sniff. And this is how to sniff part 2. Remember how I was saying with wireless traffic, it used to be, all of it was unencrypted and you could just sniff it right out of the air and it was awesome. The same is becoming true of our HTTP traffic, right? All of the traffic that flows through our web browsers and stuff. It used to be that most websites were done over normal just HTTP. Now we've seen a shift to where almost every website is using HTTPS, right? And they're encrypting all of that traffic. And so even when you're capturing on a wired interface, you're not able to see the details of what's being sent through that application layer protocol because it's being encrypted through either TLS or SSL. Well, there's a couple ways around that with either using Wireshark or using other tools. Right? So one way around it using other tools is you can set up a proxy, right, that'll receive the traffic, decrypt it, re-encrypt it with its own certificate, and send it along to your browser. And so that's one option that you can use. And in some sort of like enterprise type setting, that might be the best option. I worked at Sandia National Laboratories for a little bit, and that was what they did, right? Because it was a highly secured environment, and they wanted to know everything that was on their networks. And so we had to install custom certificates on our device that basically let them be able to decrypt all of the traffic, right? Because they, signed their certificate and our browser accepted it, and then we were still able to use the internet, but they were able to, right, monitor all of that traffic. So that's an option. When you're just capturing traffic on your home network or personal traffic or something, sometimes an easier option is your browser already knows how to capture that or how to decrypt that traffic, right? Because it's showing it to you unencrypted. And so if there was a way to have the browser's ability to decrypt and get that into Wireshark, that would solve our problem. And it turns out that we can do that. Let me start by showing what it looks like before we decrypt it. So I'm going to pull up the SSL SAINTCON capture file. And actually, well, let me check. Because it looks like maybe it's already decrypted it. Okay, it's using a different one. It shouldn't decrypt it. We'll check. Whoops.
Wizard. So please wait for the wizard to install the software. Okay.
Hello. Okay. Red mean battery's dying or just?
As IP address is kind of archaic. And so we introduced DNS long ago, in the days of IP. DNS provides kind of a phone book service for the internet. So I have to know the IP address, and I can just say, I want to go to Microsoft.com, and I don't care what their IP address is. And if I put that into my browser and go there, it will translate that for me. And so all of our computers have DNS. They use a DNS server to be able to back, okay, the name you asked for was this. Okay, this is the IP address that you want to connect to get that. And so with DNS, that's what we get. That's the way it works. You request something, a DNS request goes out from your computer, and a response comes back from the DNS server saying, I know that, or I know how you can find out that, and helps you to find the correct address. you can even buy your own out there that you can to buy a domain name. You do have to tell them what DNS servers you want to use. A lot of registrars of names will even offer their own DNS servers for you to use if you have an account with them. So, and sometimes, you know, when you pay to register with them, they'll offer those services free. TCP and UDP. TCP versus UDP. TCP
Okay, so I've had a couple of requests to demonstrate what that, using this keylog file actually looks like, where I've just, given you the keylog file. How do you get the keylog file? Right? So let's take a look at that. It's going to be a little bit different depending on your system and your environment in terms of how you set an environment variable. Let's just show the desktop. There we go. Okay, so the trick here is that in whatever environment you're using, you need to set the SSL keylog file environment variable. So I'm going to come in here to my computer under Manage, hopefully. Oh, that's not the one I want. Where is... There we go. Okay. I don't often have to set my Windows environment variables. Usually when I'm doing this, I'm just setting them in a bash shell, right, and using curl or something. So again, each system's going to be a little different. On Windows, I was able to get to my system properties through this PC properties, advanced system settings. And what we're looking for is environment variables. And we can either set them for, oh look, I did not know that I've had that set for who knows how long. I've been logging my SSL keylogs forever. Oh, you guys aren't seeing it. It went away from duplicating my display. Thanks for pointing that out. Go back to duplicate. Yeah. Okay, so environment variables, you can either set them for a specific user or system-wide. And the trick here, right, you name the environment variable SSL keylog file, and the value you give it is the path where you want it to write that file. And then every time you're using your browser, whether it's Chrome or Firefox, I know for sure those two follow this environment variable. And I also know curl follows this environment variable. Anytime you're using them and they are using TLS and have that pre-shared secret, they will write it out to this file. And so you set this environment variable first, you start your capture, you go browse to the encrypted traffic that you want to capture, you stop your capture, you come grab this file, right? So in this case, my file is located in my home directory, and I called it sslkeys.log. And I would load that file into Wireshark to then do the decryption. Okay? Other questions about using this keylog file or encrypting it? Oh, there was a question I wanted to show and demo. Someone said, okay, great, we decrypted it, but so what? Like, how do we see what was decrypted? And that's a really great question. So we showed, oh, look, now I can filter HTTP traffic and actually see this HTTP traffic in my packet list. But how do I see what that traffic was? How do I see what was transmitted and received? You can right-click on a packet in the packet list, and there's this follow option. Previously, before you decrypt it, it wouldn't have a HTTP stream as an option. Now that we've decrypted it, it's able to follow that HTTP stream, and we can pull it up, and we can see, right, the exact request and the response, and we can see all the details of that response, and then the next request and the next response. So it's all there, it's all decrypted, ready for us to go. I wasn't necessarily planning on this at this point, but it feels like a natural time to take a look at it as well. You can also come under here, under File and Export Objects and HTTP, and it will pull out all of the pieces of information that were sent as an entire object. So like if there was a picture sent over HTTP, it'll be in this list. If there was a JSON file sent, it'll be in this list. If there was a JavaScript file, it'll be in this list. So you can just come in here and export those bytes to a file, and then you have the image that was sent, or you have the HTML file, right? And so you can actually save those out as a file. So if I want to save the SAINTCON favicon image, right, I can do that. I just select it in the list, hit save. It'll ask me where I want to save it, and then I can pull it up here, and it just pulls it right out of the packets that previously that was encrypted. Now it's decrypted and able to, recognize it as the file that was transferred. All right, so other questions about TLS encryption and decryption? Yeah. That's a great question. I don't have one in these capture files. I have some logins depending on, I'm trying to think, I don't think I have any HTTP login captures. I do have like some FTP login captures in other capture files, but I don't have any in these ones. Yeah, great question. So when you're looking at that stream, where'd it go? Guess I closed it. We can follow our HTTP stream. So the red is the request, and the blue is the response. And down here, it shows some details about the stream, and it has the word client, and it puts that in red to indicate everything in red's from the client, and then blue server and puts it in blue. And that can help. It's the same, not just with HTTP traffic. You can follow, the TCP stream or whatever, and it'll use this same color coding and provide that guide down at the bottom of, the client's red and the server's blue. That's a good question. That is a good question. The question was, can we decrypt other protocols? I don't know the answer to that, as far as I've never tried to decrypt SSH traffic on Wireshark. So it may be possible, but I don't know. Okay. So let's talk about, we've figured out how to look at the packets, we've done some baselining, we've done decrypting. All of this is so that we can examine in detail what's going on our networks. And so we're to the point where we need to find the needle that we're looking for. And we've got this haystack of all of our network traffic. How do we pick out in the millions of bytes flowing on our wires the bytes that we are interested in? And this is where Wireshark can be really powerful. We talked previously about, you can capture packets with TCP dump or, other tools like that. But one of the benefits of Wireshark is that it lets you filter down and find exactly what you're looking for. And so that's what we're going to talk about next, is how to maximize our use of that. One thing right off the bat is most of the time when you're using Wireshark, you might have different use cases, like different things you're trying to find. So in one case, you might be troubleshooting a problem. Why can't my computer talk to my printer? What's going on? That's going to be a very different kind of traffic analysis than trying to answer the question, is my network compromised, right? Is someone exfiltrating data out of my network? Is someone actively exploiting Heartbleed on my devices? Answering those questions requires looking for different pieces of information. So what I like to do when I'm using Wireshark is I like to set up profiles. And profiles are basically fixed configurations or customizable configurations for how Wireshark works. Some of the things you can customize are you can customize what filters are available. We'll talk about these. You can customize coloring rules. So you might have noticed as you're looking at these packets that in the packet list, some of them are blue and some of them are green and some of them are purple. And you can customize how it colors those lists. You can customize which columns of data you're looking at. And all of those can help you find the information you're looking for more efficiently. But which things are going to help change based on what problem or question you're trying to answer. So I set up a profile for the different types of things I'm looking for. And in this case, I'm just going to set up a demo profile and I'm not looking for anything specific. But it'll demonstrate how we can use Wireshark in that way. So under Wireshark, down here at the bottom, it lists the profile we're currently using. You probably don't have this giant list like I do, because by default, it comes with like a default protocol and maybe a couple others. Bluetooth and Classic, I think, are built in. All of these others might be ones I added. So as you change profiles, it'll change different configurations that you have. So you can see when I switched from default to FTP and back, it changed this time field and what information was displaying. One of them, my FTP profile in this case, is showing the entire timestamp, whereas the default profile is just showing the relative time of the packet. And in fact, I think it's showing the relative time between packets. So how do you create your own profile so that you can start customizing what the time field looks like, or which fields are in this list, or what protocol filters are saved and ready for quick access? The way you do that is right-clicking on the profile and choosing Manage Profiles. Just making sure you couldn't do it the other way. Yep, so right-click and Manage Profiles, or you can just directly go to New. I like Manage because that gives you a little more control. And you can choose an existing profile to duplicate or make a copy of and work from that, or you can just add a brand new protocol or profile. So I'm going to start with the default profile, and I'm just going to copy that one, and I'll name it Demo, right? Because it's for this demo purpose. And click OK, and it should switch over to the demo profile. And it'll have the exact same settings as my default profile because I duplicated that one. Now I can start customizing it, and I can start changing what the time field looks like, changing these fields, adding filters that are saved. And so let's, well, I'll pause for a minute, make sure that you've got your profile, and then we'll go about creating some of these customizations to our profile. Is everyone able to create their own profile to start working from? Okay, I did find out that there's some small differences between like Wireshark on Windows and Wireshark on a Mac, so if you had to look somewhere else, looks like everyone's found it though. Okay. Yeah, right click, right, and manage or new or edit, right? So I want to make some customizations. You can customize what capture filters, like you can save capture filters. I'm not going to talk about those. And the reason I'm not really going to talk about those is because I hardly ever use capture filters. So a capture filter is good for a couple reasons. It's going to be more efficient in your capture. If you've got a lot of traffic on your device that you're capturing from, then you might want to use a capture filter and say, I don't need to be capturing all of this traffic. Right? I only need the HTTP traffic, or I only need traffic from this host. And in that case, you can set up a capture filter to limit what even gets saved to your capture file. The reason I hardly ever use capture filters is because once that's filtered out, it's filtered out at the capture process, it's gone, right? It's not available in your capture file because it never made it into the capture file to begin with. Wireshark ignored it and said, oh, that packet's not for me. Oh, that packet's not for me. And it didn't even save it into your capture file. So if you know exactly what you're looking for, or if you specifically need to limit, I can only capture traffic from these hosts because I don't have control over these other hosts, right? Those are the times where a capture filter will be useful. Otherwise, I generally stay away from them. Instead, I like to use display filters. And I use display filters all the time. Every time I'm in Wireshark, I'm using display filters. We've already used a ton of display filters as we've been going through the talk. So display filters, they limit what is seen. And everything is still captured and everything's still in that file, but it only presents you what makes it through the filter. And so it's great for focusing in on details, for ignoring everything that's not important right now for what you're looking at, but it doesn't discard that other information. So if you later need to go and look at some other packet, right, it's still there and available, and you just change your display filter and you can see it again. It doesn't give you any efficiency boost in terms of like the size of your file, because it's still going to be the same size file, right? It's all still there. But I use these, like I said, all the time. So let's take a look at using some of these display filters. We've used them. We filtered for HTTP traffic. Right? That's a basic display filter. It's a common way to start with your filtering is say, I don't know exactly what I'm looking for, but I know it's SSH traffic, or I know it's HTTP traffic, or I know it's ARP traffic. Right? And so pretty much every protocol you can filter by using Wireshark's name for that protocol. And so if I want to see all of the ARP packets, I can just ARP, put it in my filter bar, hit go, and it's ready to, and it filters out and only shows me those packets. TLS, pretty much any protocol Wireshark can handle, you can filter and say, just show me packets that are involved with those protocols. Now, when you're creating custom profiles, you can save some time and not have to type all of that out by creating bookmarks and shortcuts for these filters. Wireshark remembers your recent filters, which is great, but it also has these little bookmarks, and you can save filters. It has a few built in to start with. You can go in and clean those up, delete them, edit them, whatever, add new ones, which is what we're looking at here. So if you have a filter in your filter bar, and you're like, hey, this is a useful one, I want this in my profile, I want it so I can just click and it's there, you can save it. It'll add it to the list. Here's the expression, and here's the display name. And I'm going to change that display name to TLS. While I'm in here, I can look at this list and say, in this demo filter, I don't want a filter that only looks at IP address 192.0.2.1. That one's not useful to me. So I'm just going to remove that one from the list. And you can edit those bookmarked filters and make them exactly what you need for the traffic that you're trying to look at. Okay, so that's one place you can save filters, is here in the bookmark. Whoops, I hit cancel rather than OK. So hit OK. Now it's changed to yellow, indicating that it's a custom list. It's got TLS in our list. Oh, actually, I think it was yellow because it was applying one from the list. And they're there ready to go. Other places you can put those filters, you can have a button. So I've got a button here that applies the TCP filter. I can click the little plus button and add a new button, right? A new filter. Here's the name of the button. Maybe I want an HTTP button. HTTP is the filter I'll use. I don't need a comment. Click OK, and it adds a little button here for easy access to the filter. Okay? For more advanced filters, it can be difficult to know what to put in our filter bar. Like, we can guess the protocol name a lot of times. They're fairly common abbreviations. But if I want a specific filter, like the source port that TCP is using, well, that's a little bit trickier. How do I put that into a filter? There's some options to help you. You can freeform type it, and as you do that, it'll sort of auto-complete or bring you a list up of options. So I could say, oh, well, TCP port, that's getting closer to what I want. But I actually, I said I wanted the source port. And so you start typing and it'll come up and, oh, there's our source port filter. Now I know exactly what name it has. And I want cases where the source port was port 80. And it'll limit to now packets in this list are the ones that have a source port of 80. And as we scroll through the list, we can see all the details. They all have source port of 80, because that's what we limited our filter to. So you can type them freeform, but that's kind of tricky to get right. You can also go into the expression builder. I hardly ever use the expression builder now. I can't remember where it is. Oh, that was our list in the bookmarks. I think it's this one. Oh, started to come up. Yeah. So display filter expression under Analyze. Display filter expression. This lets you choose from all the different fields, right, and build your expression. And so you don't have to know the name. You just have to be able to find the name. Say, okay, I'm looking for an expression using LLDP, right? And maybe I care about, some specific field here, and you can choose that out, and then say that field has to be present. You can say it's equal to a certain value, greater than, less than, right? So you have all those options, and you can build it out here, and if you build it incorrectly, it highlights it in red, and when you get a valid expression, then it turns it to green. You can search for specific fields here, which can be useful in trying to find what you're looking for, and again, can be an option for creating these filters. You heard me say I hardly ever use it, which seems odd because it's kind of powerful, but the reason I hardly ever use it is because a more powerful, to me, way of doing it is in our packet details. Anything I can find in my packet details, I can filter on. And so if I can find one example of it, then I can create a filter from it. So I'm going to do a quick example. We did the source port on TCP. If I wanted to filter on the destination port, I just find that in my details list, right-click on it, and there's options to either directly apply it as a filter or prepare it as a filter, which will put it into the filter bar, but won't actually run the filter until we've had a chance to make any modifications and hit go on it. So if it's exactly what I want, and I want to filter for cases where the destination port is that value, right-click, apply as filter, selected, and it adds it in there. If it's not quite what I want, but it's close enough, then I just do a prepare as filter, hit selected, and say, oh, maybe what I actually wanted was I wanted to find everything that was greater than that value. And I can go in there and adjust it and hit go. Okay, so that's how probably like 95% of the time when I'm applying filters, that's how I usually do it, is I'll find a value that's close to what I'm looking for, apply it as a filter, modify it if needed. Okay? So lots of ways to do filtering and to save those filters. We covered most of those, looks like. Let's do some practice. Pull up your baseline capture file and go through it. Use filters. You don't have to use filters, but it's easier, right? Drill down to the information you're looking for and try and answer these questions. So what device, which IP address is the host of an SSH server? What UDP protocols are being used? And which IP address is associated with this specific MAC address? Now, if you don't know how to answer those questions because you don't know what protocol is going to help you find those answers, that's okay. I'll be around to help, and we'll demonstrate and talk about it up here up front as well. Okay? Okay, so what'd you guys find? Which host, or there could be more than one, but is a SSH server in our baseline PCAP file? Yeah. Okay, so the 3.1 address, and how did you arrive at that information? Okay, perfect. So used knowledge of the SSH protocol and said, oh, well, typically we'll find that using port 22. Right? And so you filtered for traffic on port 22. And then saw that, which one did you look at? You saw the, right, a request came from 34 to 3.1. And then later on you can see, right, the 3.1 is identified as the server, right, sends back a response. Right? Client sends the request. Okay, good. So yeah, I agree. The 3.1 right, is the server in this instance. Someone else come to the same conclusion but using a different approach. Perfect. So did you filter first or? Okay, yep. So did a filter for the SSH protocol. And then over here in the info, you saw that it was yeah. Yep. And then you see, right, these are all the clients, right? This is the server, it's the one sending the keys. Yep, here's right, it actually sending that exchange reply. And the 3.1, right? Good. And there is no cheating. If you get the information, that's the goal. The easier you can get it, the better. Okay, so let's take a look. What were some of the other questions we were trying to answer? UDP protocols. What UDP protocols are used in this capture file? DHCP? DNS? Multicast DNS? Is that it? Okay, how did you find that information? Okay, yeah. So one thing we can do, right, protocol hierarchy, look at our statistics here. Oh, crashed Wireshark. Had too much open probably. All right, let's bring our baseline back up. Check the protocol hierarchy. Under UDP, some MDNS, multicast DNS, DHCP, and DNS. Those are the ones you guys listed, right? Anyone else get the same information a different way? Perfect, right? So we can filter and say, hey, all I want to see is UDP traffic. And I've got this protocol column. I can just scroll through and check them off. Good. Lots of ways to find the information, okay? One thing, oh yeah, someone was asking about this earlier. I think maybe they already left, but they're asking about, can we see statistics over a certain time period or on a subset of our packets? So our I/O graph lets us do that, and we can choose if it's applying the filter or not on our graph. And so that can be useful there. So this is under our statistics as well. And then the I/O graphs. And you can add additional filters, and each filter can be its own chart in the graph. Last question, which IP address is associated with the particular MAC address listed here? Okay, the SSH server. Is that what everyone else got? Yes, no? Or we didn't get that? Okay. So let's see if we can figure out what's going on here. What was your approach for matching those up? Okay, so we can filter for a particular ETH address, and in this case we want this one. Okay, and then we see here both those showing up in the list, and the question becomes, well, is it the 3.1 or the 3.34? Yep. So then we can compare and line them up and say, well, this one, the 3.1, when it's a source, has Ethernet source of this address, which is not the one we're looking for, right? But the destination has the one we're looking for, and then is associated with the 34. Okay? So that's one approach for answering that question. Anyone take a different approach? Okay, yeah, so if we have an understanding of some of the protocols, the ARP protocol, that's its job, is to do what's called address resolution, right? And resolve, if I have this IP address, which MAC address is associated with it. That's its whole job. So it's a great one to filter on to try and answer this question. And yeah, so you didn't bother to then filter further because you found the answer right here on line 5425, saying that IP address is at that MAC address. Okay? Someone else used DHCP, which I thought was clever. I'd never thought of using DHCP to answer this question, but it works as well. DHCP is going sort of the other way. It's used to get an IP address, but to do that, it has to use its MAC address because that's all it has. So you can find the request for that IP address and line it up. Well, you can look at the request for IP addresses and line them up to see which MAC address corresponds there. And it, again, the 34 shows up in our list of the one that we're looking for. Destination here in that case. Awesome. Questions on using display filters? Yeah, great question. So, let's say this is a more complex file, and when we do ARP, there's thousands in this list, and we need to find the one specific one that we're looking for. Again, this is where what I would do is I would come down here to get close enough and then modify my filter. So I'd say, okay, filter to ARP, so I'm looking for one that looks like this, where it's saying, here's this IP address, here's its MAC address, and I'm going to line that up and say, okay, here's the IP address, here's the corresponding MAC address. Now let me just prepare a filter so that I didn't have to figure out exactly what the names of those fields were. And now I can just modify this with the address that I'm actually looking for. And in that case, right, now we see just that IP address with the MAC address, and would let us find that information even if there were thousands in there. Other questions? Yeah, you can. You can do ands and ors and combinations and parentheses and knots and complex logic. Most of the time what I find when I'm doing it is that I rarely have need for anything more than a single and or a single or. Like usually what I'm looking for just isn't that specific. Occasionally, so like, let me try a couple things here. Yep. No, it can go as complex as you need it to. And yeah, like you're saying, there can be a few cases where you're like, okay, I want specifically from this address on this VLAN sending this type of data, right? And you can build those filters and it'll handle it just fine. And then I saw a hand over here earlier. Yeah. Okay, so you're saying, like when we did this filter on our UDP traffic, and then instead of having to scroll through and find, okay, there's a DNS, there's a MDNS, could we just say, just show me the first instance of each of those? That's what you're asking about? That's a good question. Not that I know of, but that doesn't mean it's not possible. You can sort by any of these fields, which can be helpful. Right? So you can say, well, sort by protocol, so now when I'm looking through, I don't have to worry about one being in the middle there, because it's all the DNS first, and then all the MDNS, and DHCP must have been above those. Yep. Other questions on using our filters? Okay, so based on time, we have time for one more thing. I've got several more things planned that we could work through. Let me see sort of which one you would rather. So we can do a similar thing, but with coloring rules. So it uses syntax like filters and changes how these lines are colored. And we can talk about that and look through that. Or we can move into doing more analysis, and we can look at like the Nmap capture files and see what kind of patterns we discover as we look through those capture files. Nmap. Okay, I'm hearing votes for Nmap, so let's do that. So I've got 2 capture files here. One of them is the Nmap default, and the other one is the Nmap default baseline. I'm torn on which one you should look at first. If you've never looked at Nmap traffic, you don't know at all what to expect, I would look at the Nmap default capture file first, because that's just only the Nmap traffic, right? It doesn't have any other traffic mixed in. If you instead want to see what it looks like with other traffic occurring at the same time, then that's the Nmap default baseline. So that one has baseline traffic ongoing, and then Nmap doing a scan in the background. So both of these are demonstrating what you see on the network when someone runs an Nmap scan with the default settings. So no extra parameters or anything. They just say Nmap this network, right? And Nmap starts scanning the network. Well, what happens? What does that look like if you're seeing it in Wireshark? So take a minute, look through it, see what you find on your own, and then we'll talk about it together, some of the interesting things you've discovered. All right, so you've had a couple minutes to look over it. What have you found as you're looking at this capture file? Or these capture files? So I heard a voice, but I can't see where it's coming from. Okay. Okay, so I'm going to pull up the one that's just the Nmap stuff. And it starts out with a lot of ARP traffic. What is that ARP traffic doing? Okay, it's sequential and it's broadcast traffic, right? So it's going, who has this IP address? Who has this IP address? Who has this IP address? And this one, this one. Okay, it's all being broadcast and it's sent out to that entire network, and just saying, looking for this one, looking for this one, looking for this one. Why would it do that? Yeah, this is how, when you run Nmap, it figures out which devices are active on your network. If you just run an Nmap with the default settings, and it's doing a scan on your network, right? Not on if it's a different network, ARP won't work, and it has to do a different scan in that case. But if it's scanning on the local network, it's going to find devices by using ARP. And we can see that. We can see all of these ARP requests coming in. Okay? From a security perspective, that tells us something. That tells us if we are wondering if someone internal on our network is scanning us, we should maybe look for ARP traffic. But we can't just say, oh, all ARP traffic's bad, because we just saw in our baseline that ARP is also part of the normal functioning of the way our protocols work. So we're looking for sort of those, what differentiates it? Well, in this case, a whole bunch of ARP traffic, all sequential. And so when we see that pattern, we can say, oh, this isn't following our baseline, right? Something unusual is going on here. What happens after all of these ARP requests? Speak up. Okay, then we see a bunch of reset packets. Let's get down to those. All right, that's taking too long. I'm going to apply a filter and say, not ARP. Okay, so we see some other traffic, some TCP requests, and then all of a sudden we start seeing a bunch of these reset packets. And then more TCP requests and more reset packets. Eventually it starts looking like sort of pattern, right? So what's going on here? Yeah, so we've done the ARP scan where we were enumerating all of the devices on the network, and what you'll notice now, well, what you might notice is all of these packets are coming from the same source, right, to the same destination, and it's a whole bunch of different requests on different ports, and a whole bunch of SYN requests, right, which is the opening of a TCP connection. And so it's trying out a whole bunch of ports, this time not sequentially, but lots of ports, on a specific IP address. And so it's gone out, it's figured out which IP addresses are active on the network, and now it's trying to figure out which ports are active on that device. And the way it's doing it is just by trying to connect to a whole bunch of different ports and seeing which ones respond back and say, yeah, you can connect to this port, you can connect to this port. So the resets that we're seeing are actually a side effect of that, right? Because a lot of those are being rejected. You try and connect to this port and says, sorry, this one's closed, nothing's available here, reset, reset, reset. So those are actually a side effect, right? They're coming from the legitimate clients that are just out there doing their job, and it's this 232 that's generating all these requests. It's the one causing the problem by trying to connect to all these devices, or all of these ports. Okay? I sort of gave it away in terms of which device here is the attacker. The 232. Okay, and we can see that in the ARP requests. If we look at who's sending out all those ARP requests, we can see that in this SYN scan if we look at who's sending out the connection requests. Okay? So if you use what we applied in this file and said, okay, now I know what a Nmap scan looks like on my local network when it's occurring from a device on my local network, I want to create some rules and some filters that will help me identify that. Wireshark already has an okay one in that it's highlighting all of these reset packets in red, so they'll kind of stand out. You might want to highlight ARP packets in a different color if you're in your Nmap seeking profile or whatever, right, to make those pop out so you can notice if they are in that file and largely prevalent without having to remember to specifically check it, because it'll be a visual reminder. And that's where the coloring rules come into play. I know we sort of skipped the coloring rules, but I'll just show you where you set those. Under View Coloring Rules, you can apply custom coloring rules, and you do it by giving it a name and assigning it a filter. Any packet that matches that filter will get colored with the colors that you select. And it applies them in order, meaning it starts at the top, and the first packet that matches that filter gets the color, and then it stops, and it doesn't go on and try and see if it matches one below that. Okay? So that's how you can use coloring rules to help you as you're doing this analysis. Yep, that's exactly right. So when we come under here to our coloring rules, and we see it's got an ARP coloring rule and it's coloring it these colors, we can move that up in our list, maybe. There we go. By just clicking and dragging it up the list. So that it's the first rule that applies. And then if we're doing that, we probably want to make it stand out a little more. So I'm going to change the background color to be bright pink. So now, when I'm scanning through, those really pop out. Over here on the far right is like a preview of a larger portion of your capture, and so that can also help you, oh look, there's a big chunk of pink, and you can click on it and jump to it and analyze it. Okay? All right, well, you guys have been awesome. We're out of time, so we'll wrap up with that today. As I'm wandering throughout the con, feel free to say hi. I love meeting everyone who's here. If you have any questions, I can hang around for a minute and answer questions too. So, thank you.